Welcome to this Forge College Explainer. Today, we're figuring out the exact mechanics of transitioning from EVM to SVM, Ethereum to Solana. We are picking up right where we left off. We've done the heavy lifting of mapping out our architecture in the last lesson, but now we actually need to talk about getting the work done. Welcome to Tooling and a Migration Checklist for Porting.
Okay, let's dive right into this. You survived design considerations for porting. Congrats. But let's be honest for a second. Having a brilliant architectural theory without a concrete execution plan? Yeah, that's just going to make your project manager cry, and nobody wants a crying PM. A blueprint without a hammer is basically just a pretty drawing of a house. We need to actually turn that high-level strategy into verifiable, repeatable tasks.
So, here is the schematic overview for today's build. We're going to start by bridging design to execution, then go through the 5-phase checklist, figure out how to equip your toolchain, and walk through a real-world porting example. After that, we'll cover prototyping critical flows, and finally, wrap up with the final handoff bundle.
Section 1. From design to execution, turning theory into a concrete build plan.
Look, a subjective design brief is honestly completely useless without a rigorous step-by-step checklist. You need it to validate the exact tolerances of your migration. Think of your migration checklist as a sequential playbook. It takes those high-level decisions like, let's reshape the state, or let's split these entry points, and converts them into verifiable, objective, executable tasks. And when we say objective, we mean tasks with a clear binary state. It's either done and verified, or it isn't. No maybe, no sort of.
Section 2. The 5-phase checklist. Breaking down the build.
All right, here are the 5 distinct phases you've got to execute, strictly in order. Phase 1, pre-migration analysis. This is where you reconcile your contract surface map with Solana's account model. Phase 2, code translation, which is the actual porting of your Solidity logic over to Rust or Anchor. Phase 3, testing and validation. This needs multi-layered checks to absolutely prove behavioral parity. Phase 4, deployment and rollout. So staging, smoke tests, and rollback scripts. And finally, Phase 5, documentation and handoff. You have to move from parsing ABIs all the way to a secure staging rollout, one exact step at a time.
Section 3. Equipping your toolchain, matching the right wrench to the bolt.
Okay, you cannot just pick your development frameworks based on vibes. I know it's tempting, but don't do it. Your toolchain selection has to be explicitly driven by priority constraints pulled directly from your design brief. If your main goal is absolute safety and behavioral parity, you're going to choose a very different testing harness than a team that's just optimizing for pure developer velocity. You have to weigh performance costs against long-term maintainability. Basically, every single tool you select needs a rock-solid justification rooted in these 4 pillars.
Let's inspect the actual tolerances here. This matrix maps exactly which tool categories fulfill the functional needs of every single checklist step. For state analysis, you need ABI and storage inspectors, and you're evaluating them purely on mapping accuracy. For translation, you're looking at language frameworks based on their expressiveness. When it comes to testing, your local validators absolutely must guarantee deterministic runs. No flakiness allowed. In deployment, your CI/CD pipelines need idempotency, meaning you can run them multiple times safely, plus really strong rollback support. And for verification, your log and state diff tools have to clearly assert invariance. It's a matrix for making intelligent, objective engineering decisions.
Section 4. Real-world porting example. The vesting contract. Let's look at this massive architectural shift. On the left, you've got the old EVM centralized approach, a single token contract just hoarding all the state variables and mappings. It's literally like one giant stuffed filing cabinet. But on the right, the Solana approach. We split the vesting logic into a completely separate program, and we use precision-sharded program-derived addresses, or PDAs, for per-recipient records, while leaning on the standard SPL token account model. We are moving from a massive monolithic filing cabinet to individual, ultra-secure safety deposit boxes for every single user.
And, well, this brings up a fascinating dilemma. Say your vesting schedule references a piece of global state, right? Like a dynamic whitelist. What do? Do you centralize that data into one account and risk creating a massive bottleneck? Or do you shard it per user to reduce rent and just drastically improve parallel processing? This right here is the exact type of operational trade-off your checklist forces you to document, decide on, and ultimately validate through rigorous performance testing.
Section 5. Prototyping critical flows, building your safety harness.
Okay, the crucial point here is that you never ever deploy straight to mainnet just hoping for the best. Hope is not an engineering strategy. You absolutely need a side-by-side pseudo-test that takes no more than a single day to build. The whole goal is to prove that your translation mechanics actually work in a minimal round trip just for one critical flow.
Before you commit weeks to a full translation, your prototype has to pass these strict acceptance criteria. This prevents massive, expansive incompatibilities down the line. You must have reproducible test runs in a local validator. The performance has to actually be acceptable and fit inside your budget. You need crystal clear debugging support and log verification. And honestly, most importantly, if you feed the exact same inputs into your EVM harness and your Solana prototype, you need side-by-side output matching. If these criteria aren't met, you stop, you fix your toolchain or your strategy, and then you move forward.
Section 6. The final handoff bundle, passing the baton.
All right, so this bundle gives your ops team absolutely everything they need to run a highly controlled migration without having to awkwardly rederive your design decisions on the fly. You are handing them a precise state mapping file that links EVM slots directly to Solana accounts. You're giving them the translated modules, the thin adapters, robust test harnesses with full coverage reports, one-click deployment scripts with smoke tests, and crucially, a README, a migration playbook, and a panic button rollback plan. The whole shebang.
Remember, this highly engineered artifact is your ultimate deliverable here. The migration bundle isn't just some passive grocery list you casually toss over the fence. It is a living, executable contract between design and implementation. It ensures a buttery smooth transition from Ethereum to Solana, totally avoiding the pitfalls of assumptions and guesswork right here in this Forge College explainer.
So I want to leave you with a question to ponder. What is the single most critical smart contract flow that you will prototype first before committing to your full Solana translation? Find that flow, build your prototype, and validate your toolchain. Think about that, head over to forge.college to master the rest of your Web3 toolchain, and I will see you in the laboratory next time.